Okay, so 6.4 continued. We're going to talk about establishing identities. Part of the problem with just simplifying is that you don't always know when to stop. So the directions are going to read establish the identity, and then it'll give you a problem like this. Cosecant of theta times cotangent of theta equals secant of theta. And to establish the identity, what you're being asked to do is to prove that the left side can be simplified to equal the right-hand side. But the catch is that you cannot touch the right-hand side. So you just focus on the left side, you use your fundamental trig identities, you use algebra, and you work it down until you make it equal whatever answer they gave you. So for this one, if we start with cosecant of theta, times tangent of theta, and we have to prove that it can be simplified to equal secant of theta. Well, cosecant of theta can be written as 1 over sine of theta, and then tangent can be written as sine of theta over cosine of theta. And then just using algebra, the signs cancel out. 1 over cosine of theta is the same thing as secant of theta, which is what we wanted to force it to look like. So there we go. We've established the identity. Let's take a look at another one. So let's start with cosine of theta times the quantity tangent of theta plus cotangent of theta, and we have to prove that this equals cosecant of theta. So on the left, I'm going to leave cosine of theta as cosine of theta, and I'm going to distribute it. So this becomes cosine of theta times tangent of theta plus cosine of theta times cotangent of theta. Tangent of theta can be rewritten as sine of theta over cosine of theta. Big fat plus sign, big fat plus sign. Cosine of theta times, now tangent can be rewritten as cosine of theta over sine of theta. Over here, the cosines cancel out. We have sine of theta plus, now when you multiply this, that's cosine times cosine, so this becomes cosine squared of theta over sine of theta. Now, think of that as being sine of theta over 1, and if you want to add two fractions, you have to have a common denominator. So a common denominator for 1 and sine of theta is sine of theta, which means I need to multiply my first numerator by sine of theta. So sine times sine is sine squared of theta plus, and I don't need to do anything with this numerator because the denominator already is sine of theta. So up top, this becomes sine squared of theta plus cosine squared of theta, which is our big fundamental trig identity, and we know it's 1. And 1 over sine of theta is cosecant of theta, which is what we wanted to force it to look like. So we're done. Let's take a look at this one. Okay, so we need to prove that sine squared of negative theta plus cosine squared of negative theta equals 1. Alright, now that squared can be rewritten as sine of negative theta squared plus cosine of negative theta squared. Sine of a negative angle measure, you can pull the negative out in front. So this becomes negative sine of theta squared. Cosine of a negative angle measure, the negative drops away, so this is just cosine of theta squared. When you square a negative, it becomes positive. So this is the same thing as just saying sine of theta squared. And we'll just write this as cosine of theta squared, which we can then write as sine squared of theta plus cosine squared of theta. Fundamental trig identity, we know that's 1, which is what we wanted to prove it to equal. Excuse me. Alright, next one. We need to prove that cosine squared of theta times the quantity 1 plus tangent squared of theta equals 1. Now, for this one, if you look at the parentheses there, that's actually one of our fundamental trig identities. tangent squared of theta plus 1 equals cosecant squared of theta. So I can rewrite this problem as cosine squared of theta times secant squared of theta, and then cosine squared of theta times secant is the same thing as 1 over cosine. So secant squared is the same thing as 1 over cosine squared. The cosine squareds cancel out, leaving you with 1, which is what we wanted to prove it to equal. Alright, on this one, we have to prove that cosine over 1 plus sine equals 1 minus sine over cosine. Now, right now in our denominator, we have a 1 plus sine of theta, and I need to force a cosine of theta to appear in the denominator. So what I'm going to do is I'm going to multiply both the top and the bottom by the conjugate. So we're going to multiply by 1 minus sine of theta. Okay, so on the left-hand side, we're just multiplying both the top and the bottom by 1 minus sine of theta, which you'll notice that 1 minus sine of theta has to exist in our numerator. So I forced it to exist there, which is great. Now, down here, let's go ahead and FOIL that out. So on the top, I'm going to leave this as cosine of theta times 1 minus sine of theta. On the bottom, if you FOIL that, that becomes 1 minus sine squared of theta. Now, there is a fundamental trig identity that deals with 1 and sine squared of theta. If you look at this very first one, if you have sine squared of theta plus cosine squared of theta equals 1, you could rewrite this so that it looked like 1 minus sine squared of theta equals cosine squared of theta. So then on this problem, I know that my denominator, that's the same thing as saying cosine squared of theta. Up top, still have cosine of theta times 1 minus sine of theta. If you have 1 cosine of theta on the top and 2 on the bottom, you can cancel that one out, leaves you with 1 there. So it becomes 1 minus sine of theta over cosine of theta, which is what we wanted it to be. Okay, and we proved it.